Okay, so here in this example, we are talking about condensation polymerization. Condensation polymerization, where there are two monomers. So we are going to use two monomers. One is alcohol, one is carboxylic acid. And there are also going to be two products. What are those products? Ester and water. So how we are going to draw it here, as we have seen, we have butanol. So butanol, I am going to put here when I'm going to draw my ester. Keeping in mind, whenever, we are drawing this, what will happen? Water is going to be formed, how H from alcohol and OH from carboxylic will be eliminated to form water. Let's put aside. Now what is left? I am gonna put it here. So I'll bring alcohol first. So what I have, 1, 2, 3, 4. Butanol, so it means I have 4 of carbon. So 4 carbon, C4H9 and O, because H is already gone to form water. Now I will attach what I'll attach this propanoic acid without OH, right? So keeping in mind that we will connect it from here. Okay, so I will connect from here, CO, 1, 2, 1, 2, 1, 2, and let me move the water. 1. This is what this is my ester. What ester? Butyl. Butyl is coming from butanol. Propanoate is coming from propanoic acid. So this is what this is my butyl propanoate ester. This is what this is, basically ester linkage. Let me highlight this ester linkage. This is ester linkage where both carboxylic and alcohol groups are attaching. And of course, there is water molecules as well. So I can write water the other side. So this is how this condensation polymerization is going to happen, where alcohol and carboxylic will react to form and ester. Here in this example, butanol reacting with propanoic acid, forming butyl propanoate. Yes, so here in condensation polymerization, we have another example of polyester. Polyester, PET, PET, this is a typical polyester. And how it is going to be formed, there are going to be two monomers, since this is condensation polymerization. So how it is going to occur, let's see this. Let's have dicarboxylic acid. When I say dicarboxylic acid, means I'll have two acids of dicarboxylic acid. And then, other than that, what will I have? I'll have diol. Diol. Diol means dialcohol. Now, how I'm going to draw it, then you will understand it better. Now, let's see. Dicarboxylic means two carboxylic. There are going to be, this is going to be our group. Here we have dicarboxylic. Two carboxylic groups are attached. The main group here, you don't need to memorize the square or bracket, whatever they are using. Yeah, then diol also, it can be represented by any color. and it is going to be diol, means two alcohol are attached. So we have to apply the same concept. Whatever carboxylic or alcohols have been given, what is the main concept? That H from alcohol and OH from carboxylic will be eliminated, and then they combine to form ester linkage. What is it going to be? Now let's see. So here when I have this, what I am gonna do, OH from here and H from here, right? This is my main of the molecule that is gonna be eliminated, and the rest, I am gonna bring it down to connect. So now I'll just simply bring it down. What will happen? Here I have this HO. I'm doing step by step so it's clear to you. Now C, and now from here what? We will continue this alcohol O. And this is gonna be like this. And as we can see where carboxylic and alcohol, they are attaching, what will it be? This is going to be an ester linkage. This is going to be an ester linkage. So step by step, we are talking about like how, a polyester is going to be formed. Let me give you further more example on it so you understand how we are going to draw the continuation of bonds in the polyester, right? So this is what, we're going to say now, let's, continue. How I am going to forming this? Let me draw it. Continuation of bonds where, so I'll take this all carboxylic. All carboxylic will give off their OH bond. Alcohol will give O. So this is one repeated unit, right? In the exam, they might ask you to draw two repeated units. So what you can do, you can actually draw next, right? I am using the same colors, so like you can understand. So now again, one more carboxylic is attached, and then next one more alcohol is attached, and how this is gonna go on. Keeping in mind, there will be continuation of bonds on both sides in the exam. They will ask you where is the ester linkage. So you can circle it. Wherever carboxylic connecting with alcohol, these are basically ester linkages where, you can tell, you can highlight that this is an ester linkage. This is how a polyester is formed when alcohol and carboxylic, they are reacting together. So this is the formation of polyester. So now here in this example of condensation polymerization, we have next example of polyamide. Like in polyester, we have a dicarboxylic acid and a diol. Here we will also have a dicarboxylic acid, but it will be reacting with diamine instead of diol. So let me draw it here. Dicarboxylic acid. Okay, so a dicarboxylic acid means definitely it will have two carboxylic acids in it. And then, I'll have a diamine. Let me tell you what is that. Let's draw it one by one. So dicarboxylic acid, like I take this, I have this, yeah, two carboxylic groups attached to it here as I am drawn. And then here diamine, how I am gonna go diamine, I'll have amine group. Amine is NH2. There will be 2H with N. So now here what will happen? Similarly, like in polyester, we had OH from carboxylic acid. So all OH of carboxylic acid, and H from where? H from amine. In polyester, we had H from alcohol, OH from carboxylic and H from alcohol. It made water. Now here, this H is coming from diamine group. So now let's bring it down and then we see what is going to be made. This, we have OH is gone. So now this, right? And amine, how I am going to connect? H is gone. Sorry, not O. H is gone. Now here amine is, H is gone. So NH and H, and making sure there is continuation of bonds. Now, what is my linkage? This is basically my linkage where amine group and carboxylic, they are connecting. And what is that as they are linking? This is called amide linkage. There, I had what in polyester? I had ester linkage. Here, amide linkage. We can highlight this. This is how in the exam we will be required to show ester or amide linkage. So this is how we're gonna make sure that we have correct linkage and we have continuation of bonds on both sides. This is the main concept of drawing a polymer, that it, because since it is a long chain of molecules.